Hello, and welcome to Lesson 2.2 of the Enchanted Interpreter. In the previous lessons, we spent a lot of time working with strings, integers, and floats. Today we'll learn about a couple more data types and typecasting, which lets us convert between them. We'll start with booleans and then look at a special value called none. Then we'll learn how to check a value's type using the type function. And finally, we'll cover casting, which will be used all the time when working with user input. Let's start with booleans. A Boolean, or Bool value, represents truth values. They can be either true or false, but note the capitalization. If we print true with a capital T, we'll see true in the console. But if we print true with a lowercase t, let's run this one, we get a name error because true is not defined. The interpreter thinks that this is a variable, but we haven't defined a variable called true. So the capitalization matters. If we scroll up a bit, we do see that the one with the capital T was printed. This is because it recognizes that true is a reserved word in Python for the Boolean value true. None is a special type used to represent the absence of a value. Like bool values, none makes use of a reserved word in Python, so the first letter is capitalized. An important note is that none is different from an empty string or from zero. We can test this by doing some comparisons. In Python, we use two equal signs as the equality operator. It checks if the value on the left is equal to the value on the right, and will give you back a bool, true or false. So we can check if an empty string is equal to no value, and we can check if 0 is equal to no value. Save that and run it. And we see false both times. An empty string has a value that is equal to no characters, but it's still the type string. 0 is an integer that represents 0, but it's still a numeric data type. None, on the other hand, represents the total absence of a value. It even has its own type, which we'll look at in a moment. So anything that has a different data type, like the string that is empty, or 0, the integer, is by definition not none. This will make more sense when we actually need to use none in a future lesson. You can store bools and none in variables, just like I've done here. And then we can print them back, and we can see true, like we did earlier, or if we print no value, save that and run it, we see the none printed back to us. Now that we know a few different data types, let's talk about how to check what type something is. Python has a built-in function for this called type. Like print, the type function expects us to give it something in the parentheses. In this case, it wants the thing we're checking the type of. So I could say type of example, and this will give back the type of our example here, the data in that variable. The type function returns the value, but to see it, we'll need to print it. We can do this by wrapping it in a print statement, or by saving it in a variable. So we can say example type is equal to type of example. Then we can print example type. Save that and run it. And both times we see that it is a class string. So we get something back that looks like this. In Python, everything is an object, which is an instance of a class. And that was a lot of jargon, but we'll cover classes in a future lesson. What's important to us right now is the text following the word class. Here we have str for string. This is how we can see the types of our variables. If we change our example from a string to an integer and run it again, we have class int. We can make it a float. We get class float. And you can do the same with bool or with none. There's for bool. And none, which has its own type, class none type. This is especially useful when debugging. If your code does something unexpected, type can help you see the type of data you're actually working with. Let's try something. I've got user age as input, how old are you? And then age in decade is user age plus 10. So now I want to print how old the user will be in 10 years. You will be age and decade in 10 years. So let's run that and see what happens. Save it. How old are you? 31. And we got an error. It says can only concatenate string, not int, to string. But I said 31 for my age. Shouldn't that be an integer? Let's check the type. Comment that out. And we'll print type of user age. Save that and run it. 31. And we see that this 31 that I entered is in fact a string. Even though it looks like a number, the input function returns everything as strings. When we want to work with numeric data, we have to convert the string or cast it to an integer or a float. Python has built-in functions for typecasting. They are int, float, string, and bool. So in this case, what goes in the parentheses is the value that we want to convert to the function outside of the parentheses. So if we want to convert user age to an int, we would put that in the parentheses there. To a float, we would put it in the parentheses here. So in this case, let's update our user age to be int user age. Then we can uncomment these two lines, comment out that one, and let's try running it again. How old are you? 31. Then it will convert that 31 to an integer, and then create age and decade as 31 plus 10. So I'll see you'll be 41 in 10 years. Some things to note about typecasting. Whenever we convert a float to an int, it doesn't round the value. It simply drops the decimal portion, only returning the whole number. So here we have pi is 3.14, and pi as an int is int pi. Let's print pi int. I've got an extra space there. Save that and run it. We just see 3. If we made this something like 3.9, which would round up to 4, run it again, we still just get 3. Another interesting thing about typecasting is when we use it to convert something to a bool. In Python, we have what's called truthy and falsy values. Truthy values are ones that will become true when converted to a bool, and falsy values will become false. Some examples of falsy values are 0, none, and an empty string. Empty containers like lists and dictionaries will also be falsy values, but we'll cover those in a future lesson. Truthy values are anything else. So the value 0.0000000001, however small it is, will still convert to true. A string with the text false in it will also convert to true. If there's data there, it will be a true value. Empty strings, none, and 0 will be false. Some values can't be converted to certain types. For example, if I try to get the int value of none, we'll get an error. Let's run that. Comment these out. Int argument must be a string, a bytes-like object, or a real number, not none type. This is because none has no numeric type. It's not the same as 0. It has no int value. You also can't convert non-numeric strings to ints or floats. So if I say hello and run that one, we get a similar issue. Invalid literal for int with base 10, hello. Almost anything can be converted to a string, though. Here we have string none and string true, none type and a bool value. Let's run this one. And we see none and true. Note that these here are strings, not the actual bool value or none value. Now for an exercise. Make a mini calculator program that asks the user for two numbers, the first an int and the second a float. Convert them appropriately, and then multiply them. Print back the result. How'd that one go? Here's how I did mine. Number 1, we wanted an integer, so I said input, enter an integer, and then on the second line, I convert that integer I convert that value from the input to an integer and save that back in the number one variable. For the float, I did it all in one line. So first, I asked for the input, enter a float. Once I enter that value will get passed to the float function and get converted. The converted result is what gets saved to the number two variable. Then we do answer is equal to number 1 times number 2. Remember for multiplication we use the asterisk. And then we can print our result. I used an F string. So F string number 1 in brackets times number 2 in brackets is answer in brackets, because the brackets are where we put our variables. You could do the same thing with concatenations, but remember, you can only concatenate strings with other strings. Number 1 is an integer, number 2 is a float, and answer is a float. So we have to make sure we convert each one before we try to add them or concatenate them to our text. But if I run this, 7 and 2.4, or 2 and 2.4, and we see 2 times 2.4 is 4.8. And we see it printed both times because I have the F string version and the concatenation version. And with that, you're ready for the challenge. Head to the GitHub repo linked in the description for the story content and the challenge for this lesson. A solution will be linked there as well, but give it a try first. Thanks so much for watching, and I'll see you in the next lesson.